Hello guys and welcome back. So now we're going to start looking at the turbulence forces that we have available for us to use in the DOP network. And I'm going to create a simple fluid sim. So I'm going to source some density. I'm going to create smoke. And I just need some density here. So So what I'm going to do is I've started with a sphere. I'm going to convert this into a volume instead of surface. I'm going to increase the voxel so we don't have a lot of resolution, something like that. And I'm going to call it density. That's all I need. And then I'm going to create a null, call this out density. And let's dive inside. I'm going to create a smoke solver. And I'm going to create a smoke object. Connect these two. Source volume. And let's do the toggle. Accept. And then let's increase the boundary. So I'm going to create a bound node here just to get an idea about the values that we need to use. So 50, 25 on all axes. Something like that, and then we can move it up. And let's add a gas resize field. Let's change this to one at gas resize field. Gas resize field dynamic. Cool. So let's hit play. Nothing happens. Let's see why. Let's set this delay to 1. So we get some frames, and let's increase this to 50. And what I want to explain in this video is I want to show the turbulence available in Houdini and how to use it. And right now we don't have anything to push this volume upward, so I'm going to create another field. I'm going to create another field that is a copy of the density and use that as the temperature to have something that can push the volume upward. So we can hack this in the source node under the sub binding. We can tell it to look up, instead of this temperature volume is looking for the temperature, we can tell it to look for density, and that will inject the density into the temperature every frame. So now you can see we have the smoke rising. I'm going to turn off the clamp to maximum, and we should have something extending. Let's see. Yeah, we should have something extending. I'm not so sure why not. Let's increase this a bit. Let's add some more padding to this, maybe 2. And let's hit play again. Okay, now it's working. And as you can see, we have smoke emitting. I'm going to lower the density of the volume. I'm going to hit play. Okay, cool. So we have smoke going upward. And I'm going to import this so we can see it. Import fields, and let's import smoke object 1. Sorry. And set this to smoke. Okay, let's create a light. And let's go back and let's copy this and create another one from this area, and let's reduce the illumination and change the color a bit. Okay. So what I'm going to do is I'm going to play with the turbulence that we have available, and there is there's not a lot of nodes. There's only a handful. The first one is called gas turbulence. Second one, gas disturbance. I'm gonna put down a gas dissipate because we need it as well. And then gas vortex confinement. And gas shred. Let's move these guys away. And then gas disturb. So these are all the turbulence that we have available to break this up, and we're going to learn how to use them. So I'm going to create a merge node, and I want to plug that into the velocity, and let's start with this one. And all of these guys are basically OTLs or HDA. They are subnetworks. And this layout here is just exposing certain parameters that the side effects guys decided to expose so we can use them. But if we right click and say allow editing content, we can dive inside and see how it is actually made. And you can see it's made of a bunch of nodes, and the first one is copying a channel, and then there's this this compute turbulence, and it's a gas field VOP. And this is basically a VOP network similar to how we do things in SOPs. And all it comes down to is basically this guy, a kernel noise. This is what this node is doing. It's applying a noise and then exporting that and applying it to the val, the velocity, and then that will disturb the velocity field basically. And it's basically a noise that gets generated based on, if we look at the input here, it takes the position, and what the position is, it's the position of the voxels and with the time, so it changes over time. And then that gets copied into the val properly because it's been put into a force val temp, so that gets copied to the temp val, and then this is the OpenCL version for it. And this is like the main noise that we have available. So we're gonna try and see how it works. Let's increase the scale, and this is the control of the kernel noise. You can see now it's much stronger. And let me go up. I want to look at it in the viewport here. So what I'm going to do is I'm going to reduce this a bit. Okay, and I'm gonna pin this viewer so we can see it lit all the time. Okay, so let's continue. So that's the scale. Okay, let's increase the swirl size and see how that affects it. We're getting bigger blocks, and it's very important. Sorry, we're getting bigger blocks. Yeah, it's very important to understand that this is based on the position of the voxels. So the more voxels you have, the more details you will see, and probably it's gonna differ from the low res to the high res. Let's increase this to 10. Actually, let's lower this to 0.1. So you can see it's generating smaller details here. And then let's increase the gain. Let's put this back to 0.05. This intensity is very strong though. You can see it's much sharper. There's a bigger contrast between the area affected versus non-affected. And then let's see. And then these are all the controls. You can what I would recommend doing is create a grid and scatter some points and take a look at what a kernel noise map will look like, the noise pattern will look like. And from there, you will fully understand how these maps will affect the volume. But overall, what I'm seeing right now is, even at this low res low resolution, I'm seeing a lot of uniform repetition here, and it's affecting everything equally. There is no change between the fast moving parts and the part that is supposed to be dissipating. And they have a control for that. There's this control field, and we can tell it to use the density. But right now the density is not changing too much. It's pretty much uniform. So I want to add a gas dissipate to change the density over time. And let's plug this in here, and let's evaporate the density a bit. Okay, you can see it here, it's dissipating. Cool. Okay, so this guy is dissipating a lot. And what we can do is we can take this map here and tell it to, we can take the density field and tell it to use that as a mask for where to apply the noise. And we have to basically tweak the values. What I like to do generally is remap the field, and then I can remove all the low density parts, and this will leave it to be just applied for the high density. Now the min and max is the range of the density field, and right now it's assuming that it goes from 0 to 1. It depends on the scene that you have, and you have to find the correct values. I'll show a method how to find the maximum density and the minimum density in a later video that will help us identify these min and max. And right now you can see by doing that we're isolating the force to be applied only on certain areas, but we're also affecting that part. So we have this control, and then this does not change. This is just the settings to tell which field to use. So this is the first one. I'm gonna turn it off for now, and you can see with this guy we're getting, let me put back the settings so we can see more details. With this you can see that the patterns generated on the volume feels like they are static in the environment. Feels like the smoke is going inside a field and then is just getting modified. And here it looks very uniform. Overall it looks very uniform, and it's not it's quickly causing the mushroom effect, which is something we don't want to. It doesn't happen in real life this much. So we don't want areas that are big and moving slowly like that without having any details on them. And you can see basically anything that is left after this is getting disturbed. And you can see it here. This is actually a perfect example. You can see a uniform pattern, and the smoke is just swimming through that. You can see it here. You can see the smoke is just swimming through that noise pattern, and this is really bad. We don't want this. We want something much more clever that can understand the silhouette of this shape and apply the noise properly. So this is one of the main limitations of using the cast turbulence or applying any kind of forces to the velocity field that uses the voxel location, because what that will do is it will generate a smoke that swims through a pattern. And let me illustrate the effect. So I'm gonna create a sphere. I'm gonna increase the density of the points, and I'm going to create a point vault. Dive inside, and let's create a curl noise. And it was set to the analytic. Can't remember which one. We'll try this guy. And let's use P, and let's add that to P. And let's lower the amount. Cool. So we have this pattern. And what's happening now? It's interesting. We get a lot of nice shapes, but once we start, let me copy this. Once we start moving this geometry, you will see how the sphere is. It's basically swimming through the noise pattern. There is nothing that follows the shape. And see it here? You can see it here basically clearly. It's not generating interesting patterns. It's just disturbing and distorting the volume in a very unrealistic way. And we don't want this. This is very basic. And this is one of the main limitations with the gas turbulence. But that's what we have. So it's the main node that Houdini provides. Then we have a gas disturb, which basically disturbs the velocity channel. And let me play again. Let me play the sequence. Okay, let's, I want some lighting. So I'm gonna pin the viewer again. Let's go back. And let's increase the gas disturb. And you can see how it is disturbing the field. And this is probably more interesting than the gas turbulence, but again, we cannot push it too far. It starts creating this kind of effect as well. And this is affecting directly the velocity field, not just adding some turbulence, it's changing the velocity field itself. But we can use it to add some fine details like this. We can use it at a lower threshold to create some fine details. I don't think it's problematic. So that's one guy. And then the gas shred is basically what it says. It's gonna try and break the pattern, and it has a noise as well. And the noise that it has is based on a random generator. It's not even a noise pattern. It's just a random function inside that results in randomization, and that gets used to disturb the velocity field. So you can see it here, breaking up everything we have. But so far you can see as soon as we increase this value, we're losing everything about the sim. It's getting completely broken up, and we don't want necessarily that. You can see here as well that even with this value, we're not breaking this. It's always behind or what's left over that gets affected. We're not breaking the mushroom effect, which is another big problem that we have to fix. And so this one we can use, but we have to be careful with the amount that we use it by. And then a gas disturb, I think I covered that. Yeah, covered that. The gas dissipate, we covered that. And then the gas vortex confinement, this one I really like because it analyzes the volume, and based on that it enhances the movement of the smoke to, let's say if it has, I'll try to explain it. So for example, this smoke here has velocity change. The velocity is changing, but we can find areas, for example here, where the velocity is not changing too much. The smoke is not moving too much, but it's rotating and moving left and right without necessarily moving too fast in terms of unit scale. And that change in velocity is called curl. You can see it a lot in fluid surfaces where you have, for example, foam next to a rock. You can see the foam is the fluid is rotating a lot in there, but it doesn't have high velocity and it has a high curl. So you get a lot of curl in that area. And what this node does, it analyzes that curl and enhances it, which is very important. So if we want, for example, if we see some areas here that is rotating because of this gas turbulence, this guy is going to enhance that. And it's this one is not going to affect the swimming part. It's going to just improve whatever velocity is doing. It's going to improve upon that. And let's see if we can increase it to a very high value. Yeah, it's too much. Let's try 10. I generally set this to 5, between 5 and 6. And again, doing the high-res version will always show will always show the final details. Now you can see again we're still having that mushroom cloud, and we're still having the uniform scale of the turbulence field. And these are the default Houdini nodes as far as I know. And then in the next video, we're going to see how these guys are utilized in the PyroSolver after we understand what the purpose of the PyroSolver is. Thank you so much for watching, and see you in the next video. Bye-bye.